Tonight we are exploring something invisible yet profoundly present in every moment of your existence. 4 forces shape the universe in ways you have never fully considered, though their effects surround you constantly. These are the fundamental forces of nature, and they operate at scales from the infinitely small to the incomprehensibly vast. They govern how atoms bind together, how planets orbit, how your heart beats, how light travels through the cosmos. Most of us move through life without thinking about these invisible architects at all. We feel their effects but rarely ask what they are or why they matter. Yet understanding them opens a window into the deepest mechanics of reality. There is something profoundly humbling about recognizing that your existence, this entire world, the stars and galaxies beyond, are all held together by forces you cannot see. You have never seen gravity, yet it shapes you. You have never seen electromagnetic force, yet it powers your thoughts. You have never seen the nuclear forces, yet they hold your very atoms together. These 4 forces are like the 4 pillars of creation, silent and invisible, yet absolutely fundamental to everything that is. Tonight we will begin that journey together, moving quietly through the realm of force and energy. We will discover why the universe holds together, why matter behaves as it does, and why nothing could exist without these 4 invisible forces working in concert. Allow yourself to be curious. Let your mind settle into wonder. There is no pressure to understand everything immediately. This is a slow exploration of the forces that control everything around you. Breathe deeply. Let the weight of this knowledge settle gently on your shoulders. And let us begin. Gravity is the first of these invisible forces we will explore. It is the force you feel most directly in your life, the constant pull that keeps your feet on the ground and shapes every movement your body makes. You are aware of gravity in ways you might not even realize. Every time you pick something up, every time you walk, every time you sit, you are managing gravity. The weight you feel, the exhaustion in your legs after climbing stairs, the way things fall when you drop them, all of this is gravity at work. Gravity is profoundly weak compared to all other fundamental forces, yet somehow it is also the most obvious. This paradox lies at the heart of understanding gravity itself. It is the weakest of all the fundamental forces, yet we experience it constantly and directly in ways we experience no other force. It operates everywhere, pulling on every object that has mass. Gravity has infinite range, meaning that every object in the universe is technically attracting every other object, no matter how far apart they are. The strength diminishes with distance according to a precise mathematical law, but the pull never truly reaches zero. Even now, your body is attracting the stars. Even now, the stars are attracting you. The pull is infinitesimally small, but it is real. Gravity is always attractive, never repulsive. Unlike the other forces, it only pulls things together. It never pushes. This simple fact has profound consequences for how the universe is structured. All matter naturally wants to come together through gravity. All massive objects in the universe are slowly pulling toward each other. This has shaped the structure of the cosmos. Let us now explore gravity in all its aspects, understanding how this weakest of forces shapes the world we inhabit. Consider the remarkable comparison that illustrates gravity's weakness in the most direct way possible. The entire mass of Earth, this vast planet with its oceans containing billions of tons of water, its continents of stone, its dense iron core burning in the darkness deep below, is needed to hold a single iron nail to the ground. The combined gravitational pull of all that planetary mass, accumulating across billions of years of existence, is just barely sufficient to keep a small piece of metal on the surface. Yet with something as small as a magnet, something you can hold in your hand, something weighing perhaps just a few ounces, you can overcome the gravitational pull of the entire planet. You can pick up that nail with a tiny magnet and lift it upward, defying the pull of all Earth. SS mass. The nail rises toward the magnet. It moves against gravity. It does what gravity says it should not do. This is astonishing when you really sit with it and think about it. A simple magnet, a device so common we think nothing of it, can do what the entire planet cannot. The electromagnetic force is stronger, far stronger than gravity on small scales. This single comparison reveals the profound weakness of gravity. Yet gravity dominates at large scales because all objects with mass contribute their gravitational effect, and these effects accumulate. Over vast distances and immense spans of time, gravity becomes unstoppable. The small can be overcome by other forces, but the cosmic cannot be resisted. Gravity has the last word at cosmic scales. Gravity follows a precise mathematical pattern called the inverse square law. This is one of the most elegant discoveries in physics. When you double the distance between two objects, the gravitational force between them becomes 1/4 as strong. When you triple the distance, it becomes 1/9 as strong. The pattern continues with mathematical perfection. This relationship holds true everywhere in the universe, from Earth to the most distant galaxies we can observe. It is as if the universe itself speaks in the language of mathematics, and gravity is one of the clearest words it speaks. It means that gravity diminishes rapidly with distance. Close together, gravity's pull is strong. Far apart, it becomes weak. Yet it never reaches exactly zero. Two objects separated by light years of empty space, by distances so vast they are incomprehensible to the human mind, are still technically attracted to each other through gravity. The force is infinitesimally small, so small that no instrument could ever measure it directly, but it is there. This mathematical precision is one of the beautiful aspects of gravity. It is not random or chaotic. It does not behave unpredictably. It follows laws that are predictable and repeatable. This allows us to calculate the motions of planets and stars with remarkable accuracy. We can predict where a planet will be in the sky centuries from now, because we understand gravity's mathematical nature. Gravity influences muscle contraction in ways you might not realize, though you feel the effects of this every waking moment. Every muscle in your body must generate enough force to overcome gravitational pull. The fibers in your muscles are contracting right now, at this very moment, working to keep your body upright against gravity's constant downward force. Even when you are resting, apparently doing nothing, your muscles are active and working. Your postural muscles are constantly engaged, fighting gravity to maintain your position. When you move, your muscles must work even harder because they must not only accelerate your mass in the direction you want to go, but also fight against the constant pull downward. The way you walk, the speed at which you can move, the strength you can generate, all of these are fundamentally shaped by gravity from your earliest moments. If you suddenly found yourself in weightlessness, say in a spacecraft orbiting the Earth, your muscle contractions would become completely different. You would not know how to move properly. Your muscles would flail in directions that make no sense. Your entire neuromuscular system, from birth onward, is trained by gravity. Every neural pathway, every motor pattern, every learned movement skill develops in response to gravity's presence. Gravity shapes your bone density throughout your life in ways that are quite profound and far-reaching. Your bones are strongest when you move against gravity regularly, placing demands on your skeletal system. When you exercise with intention, when you walk through your day, when you simply stand and move about, you are placing stress on your bones. This repeated stress, this constant challenge posed by gravity, triggers your body to maintain and even strengthen bone density. Your skeletal system responds to these demands by reinforcing itself. But when gravity's stress is removed, something remarkable and troubling happens. Astronauts who spend weeks or months in weightlessness experience rapid bone loss. They lose bone density at a rate that would take elderly people years to experience. Their bones become weaker and more fragile, because gravity is no longer challenging them to maintain their strength. When they return to Earth, they must rebuild that strength slowly, sometimes taking months of rehabilitation. This remarkable demonstration shows how fundamentally important gravity is to your physical structure. Your bones would be weaker and more fragile if gravity were not constantly challenging them, pushing them to maintain their integrity. Gravity is essential to heart function, though we rarely think about the extraordinary effort your heart expends fighting this simple force. Your heart must pump blood, not only to circulate it throughout your body, but to pump blood upward against gravitational pull. This is a tremendous effort your heart undertakes with every beat. The cardiovascular system is designed with gravity in mind. The heart must be powerful enough to lift blood against gravity's constant downward attraction. Veins in your legs must work to push blood back up to your heart against the downward pull of gravity. They have one-way valves that prevent blood from flowing backward. Over time, from years and decades of fighting gravity, this constant work can cause problems. Veins can weaken. Varicose veins develop when the walls of veins lose their strength from years of fighting gravity's pull. The blood pools in these weakened vessels, creating visible bulges and knots. Circulation to various parts of your body is affected by gravity. Blood flows easily downward but must be actively pumped upward. This is why you might notice your feet swell after standing for long periods. Gravity is pulling blood downward into your extremities and making it harder for your body to push it back up to your heart. Balance and stability are entirely products of gravity's presence and your nervous system's constant response to it. Your inner ear, that delicate spiral of bone deep within your skull, is filled with fluid that responds to gravitational pull. Your proprioceptive system, the network of sensors throughout your body that tells you where your limbs are in space, depends entirely on gravity's presence to function. Your sense of where your body is in space, this thing you take completely for granted, is a gravitational sense. Without gravity, you would have no sense of up or down. You would not know which way to orient your body. You would become disoriented and confused. Every moment of balance you experience, every moment you stand upright without falling, every moment you walk in a straight line, is your nervous system responding intelligently to gravitational pull. When you walk, you are constantly adjusting for gravity with each step. Your muscles are fine-tuning your position to resist gravity's pull. When you sit, gravity holds you to the chair through the electromagnetic forces between atoms, but you perceive this as weight and pressure due to gravity. When you stand, you are actively and continuously fighting gravity to maintain an upright position. All of this requires constant muscular and neurological effort, a coordination so complex that no robot can yet replicate it perfectly. Gravity dictates the forces you need to generate for walking in 1,000 subtle ways. The way your legs move, the rhythm of your gait, the power in your stride, the timing of each step, all of these are shaped fundamentally by gravity. Children learning to walk are learning to coordinate their muscles in response to gravitational pull. They are developing neural pathways that predict where gravity will pull their body and how to counter that pull. Elderly people who have weakened muscles struggle with walking because they cannot generate enough force to propel themselves forward against gravity. Walking becomes dangerous for them because their muscles cannot overcome gravity's pull sufficiently to maintain stability. Walking is such a natural act that we rarely think about it, yet it is fundamentally a way of managing gravitational force. Each step forward is a victory over gravity. Each foot planted on the ground is a negotiation with gravity. The grace of human movement emerges from our lifetime of learning to move skillfully within gravity's constraints. Gravity shapes the mechanics of movement throughout your body in countless ways, both obvious and subtle. When you throw a ball, gravity affects its trajectory. The ball follows a curved path because gravity is constantly pulling it downward. The farther you throw it, the more time gravity has to pull it down. When you jump, gravity pulls you back down. You can only stay in the air for a fraction of a second because gravity is relentless in its downward pull. When you run, gravity is constantly pulling your body toward the ground, and your muscles must work to propel you forward despite this constant downward force. Each running step requires your muscles to overcome gravity while also accelerating your body forward. It is a complex dance of forces. The way athletes move, the way dancers leap, the way anyone moves through space is all fundamentally influenced by gravity. An athlete's power is measured by their ability to accelerate against gravity. A dancer's grace emerges from their mastery of moving with and against gravity's pull. Gravity takes a toll on your circulatory system over time. If gravity can prevent water from flowing uphill, it can certainly affect the movement of blood in your body. Blood circulation to your eyes, ears, skin, and scalp is affected by gravity. As you age, gravity literally pulls on your tissues, affecting your appearance and the health of your organs. This is part of why aging occurs. Gravity is constantly working against your body, pulling it downward, affecting circulation, affecting the structure of your tissues. Your most valuable organs deteriorate, partly because of gravity's constant pull. Water drainage in your home depends on gravity in ways that are absolutely fundamental to modern life. Without gravity, water would not flow downward through your pipes. You would have to manually move water out of your sink or tub after every use. The water would have nowhere to go. Gravity makes plumbing possible. It allows water to flow downward naturally toward the earth. Without gravity, plumbing systems could not function. Every building would need additional equipment just to move water away from living spaces. It is why you must tilt your sink slightly to drain it properly. The angle matters because it allows gravity to pull the water in the right direction. It is why pipes slope downward. If pipes went upward, water would not flow through them at all. Every time you wash dishes or take a shower, gravity is working silently to remove the water from your space. Water falls from your shower head because of gravity. It drains away because of gravity. We take this for granted, but without gravity, basic household water management would be impossible. Civilization itself depends partly on gravity's role in removing wastewater. Cooking would be entirely different without gravity, perhaps even impossible in some forms. When you pour water into a pot, gravity pulls it downward, filling the container from the bottom up. When you tilt a pan to distribute oil across the surface, gravity helps that distribution by pulling the oil downward across the heated metal. When you drain pasta, gravity pulls the water down through the strainer, leaving the pasta behind. Without gravity, you would have to manually push the water away. Recipes themselves are partially designed with gravity in mind, though we rarely think about it. Certain foods naturally separate or layer because of gravity. Oil and water separate partly because of their different densities and gravity's effect on those differences. The way ingredients behave in water, the way sauces settle and thicken, many of these processes are influenced by gravitational pull. Gravity helps ingredients mix by pulling them downward. Gravity helps separation by allowing denser ingredients to sink. Every cooking technique is subtly influenced by gravity. The water cycle that sustains all life depends on gravity. Water evaporates from oceans and rises into the atmosphere, but gravity is constantly pulling that moisture downward. When enough water condenses into clouds, gravity overcomes the upward movement of air, and water falls as rain or snow. Gravity is the force that brings water from the sky to the land. Without gravity, water would float away into space as vapor. The entire cycle of water would not function. Crops would not receive rain. Freshwater sources would not refill. Life on Earth depends on gravity to circulate water. Rain is gravity pulling water from clouds to the ground. Snow is gravity pulling frozen water from the sky. Hail is gravity pulling ice pellets downward. Every form of precipitation is fundamentally driven by gravity. The amount of water that falls from the sky, the patterns of rainfall around the world, these are all influenced by how gravity pulls moisture downward. Deserts exist in some places, partly because gravity and atmospheric conditions prevent moisture from reaching certain regions. The distribution of water on Earth is shaped by gravity. Tides occur twice daily because of gravity, a phenomenon that has fascinated humans since ancient times. The moon's gravitational pull affects the oceans of Earth. Though the moon is far away, its gravity is strong enough to pull on water across vast distances. The sun's gravitational pull also affects them, adding to or subtracting from the moon's influence, depending on their positions. These two gravitational forces create a bulge in the ocean water, causing tides. The water literally rises and falls as gravity pulls on it. As the Earth rotates, different parts of the planet experience high and low tides. This daily cycle of tides influences marine ecosystems profoundly. Fish and other creatures time their behaviors around tidal cycles. The tides affect human activity along coasts, influencing fishing, shipping, and coastal development. Tides demonstrate gravity's reach across the vast distance between Earth and Moon. The Moon is roughly 250,000 miles away, yet its gravity reaches across that enormous distance and moves the oceans. Tides show us that gravity operates on scales we cannot even perceive directly, yet its effects are unmistakable. Ocean currents are partly driven by gravity in ways that are central to understanding how our planet works. The movement of water across vast distances in the ocean is influenced by gravity working in combination with other forces like wind and the Earth's rotation. Gravity affects the density of water, which influences how water moves. Salty water is denser than fresh water, and gravity pulls it differently. Dense, cold, salty water sinks because gravity pulls it downward. This sinking creates currents that move along the ocean floor. Warm, lighter water rises because gravity pulls less strongly on it. These density differences drive some of the great ocean currents that redistribute heat around the planet. The Gulf Stream, one of the most important ocean currents in the world, moves warm water northward because of gravity working with other forces. This current influences the climate of Europe and the eastern coast of North America. Without gravity, oceans would not have their characteristic circulation patterns. The oceans would be stagnant and lifeless. Climate patterns around the world are influenced by gravity's effects on water and air in profound and interconnected ways. Gravity pulls air downward, creating atmospheric pressure. The weight of the air above us creates pressure on the surface. Differences in atmospheric pressure drive winds. Air naturally flows from areas of high pressure to areas of low pressure, and gravity's role in creating these pressure differences is fundamental. Gravity affects how water evaporates and condenses. When water evaporates from the ocean, gravity allows that vapor to rise into the atmosphere. As the vapor cools and condenses, gravity pulls the water droplets downward as rain. Gravity influences ocean currents, which transport heat around the planet. All of these are crucial to climate. The tropical regions receive more solar energy and must transport excess heat toward the poles. Gravity, working with other forces, helps drive this transport. Without gravity's influence on atmospheric water vapor and ocean currents, climate patterns would be completely different. The tropics would be impossibly hot. The polar regions would be even colder. The intermediate latitudes would lack the stability that allows life to thrive. The stability of Earth's climate system depends partly on gravity doing its work, moving heat and water around the planet in carefully balanced patterns. Atmospheric water vapor is pulled downward by gravity, but it is held aloft by air currents that fight against this constant downward pull. The balance between gravity pulling downward and atmospheric circulation pushing upward creates the water cycle. It is a constant struggle between gravity trying to pull water down and the heat energy in the atmosphere trying to push it up. Weather systems are partly shaped by gravity acting on air masses of different temperatures and densities. Heavy, cold air masses sink because gravity pulls them downward more effectively. Light, warm air masses rise because they are less dense. Thunderstorms develop partly because gravity pulls cool air downward, creating instability in the atmosphere. The storm is like a battle between gravity pulling air downward and the heat energy trying to push it upward. When the rising air cools in the upper atmosphere, gravity regains the upper hand and pulls the air downward, creating the downdrafts in thunderstorms. Gravity is not a background force in weather. It is an active participant in every weather system on Earth. Plant growth is influenced by gravity in ways that might not be obvious, but are absolutely essential to plant development. Plants sense gravity and grow upward against it. A plant's leaves and flowers point upward toward the sky, away from gravity. Roots grow downward into the ground because gravity influences how plants distribute their growth hormones. The plant knows which way is up by responding to gravity's pull. The structure of a tree, the direction its branches grow, the way it distributes its weight, all are influenced by gravity. A tree's trunk grows upward and strong to support branches against gravity's pull. The roots grow downward to anchor the plant and gather water and nutrients. If you grow a plant in weightlessness on a space station, it grows in random directions. The plant cannot determine which way is up. Without gravity to provide directional information, the plant's growth pattern becomes chaotic. Gravity gives plants a sense of which way to grow, and this directional sense is essential to the plant's survival. Gravity affects all falling objects equally, a remarkable fact that reveals something profound about the nature of gravity itself. This is one of the great insights of physics. A feather and a hammer fall at the same rate in a vacuum. Despite their enormous difference in mass, they accelerate downward at exactly the same speed. Gravity does not care about the mass or density of an object. It affects all objects the same way. This equal acceleration is true for a grain of sand and for the planet Jupiter. This simple principle was demonstrated long ago and revolutionized our understanding of gravity. It means that gravity is not a property of individual objects, but a property of space itself. Gravity is the geometry of space, the way space itself curves in response to mass. This is one of the deepest insights modern physics has provided. Gravity keeps planets in orbit around stars, creating the structure of planetary systems throughout the universe. The Sun's gravitational pull keeps all the planets of our solar system circling it. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune all orbit the Sun in stable patterns maintained by gravity. Without gravity, planets would fly off into the darkness of space in straight lines, never to return. They would disperse throughout the cosmos. Orbits are stable because gravity is constant and reliable. The Earth orbits the Sun at the same distance year after year because gravity pulls with the same strength. This consistency is remarkable and essential. This allows life on Earth to exist in a relatively stable environment. The climate patterns we experience, the seasons we recognize, all depend on the stability of Earth's orbit around the Sun. If our orbit were different, if gravity was slightly stronger or weaker, Earth's climate would be completely different. Civilization itself has developed in response to stable seasonal patterns that exist because of gravity's reliable pull. Gravity holds galaxies together across vast spans of space and time. Billions of stars are bound in galaxies by mutual gravitational attraction. Each star is pulling on every other star in the galaxy. The cumulative effect of all these gravitational pulls creates the structure of the galaxy. The Milky Way, which contains our solar system, is held together by gravity. It is a spiral galaxy containing roughly 200 billion stars, all held together by mutual gravitational attraction. Without gravity, the galaxy would fly apart immediately. Stars would drift off into space in all directions. The very structure of the universe, the existence of galaxies themselves, depends on gravity binding stars together into coherent systems. Galaxies have persisted for billions of years because gravity keeps pulling them together. Gravity shapes the large-scale structure of the universe across scales so vast they challenge our understanding. Vast filaments of galaxies stretch across billions of light-years of space, held together by gravity. The universe is not randomly distributed or homogeneous. Instead, it has intricate structure. Galaxies cluster together into groups. Superclusters of galaxies cluster together into larger structures. All of this structure is held together by gravity. Gravity is the dominant force at cosmic scales, overcoming any local variations and binding the universe into a coherent whole. From the smallest human body to the largest galaxy cluster, gravity shapes structure everywhere. Gravity is weak on small scales, but becomes dominant at cosmic scales, displaying a remarkable pattern of increasing importance at larger and larger distances. This is perhaps the most important thing to understand about gravity. It is weaker than all other forces when you are dealing with individual atoms or molecules. The electromagnetic force is far stronger than gravity at atomic scales, but once you accumulate enough mass, gravity becomes the dominant force. The accumulated effect of trillions upon trillions of atoms' gravitational pulls becomes significant. On the scale of people and objects, gravity is the obvious force. You experience gravity with every moment of every day. On the scale of planets and stars, gravity is dominant and utterly inescapable. On the scale of the universe, gravity is the force that shapes everything. Galaxies, galaxy clusters, and the universe itself are structured by gravity. Gravity presents one of the greatest paradoxes in physics, a contradiction that reveals something fundamental about the nature of reality itself. It is the weakest of all forces, yet it is the most obvious in our daily experience. It is the weakest, yet it dominates the universe. It is the weakest, yet it is what holds you to the ground right now. You feel gravity constantly, yet the other three forces are far more powerful on small scales. This paradox contains a profound truth. Gravity is weak, but it is relentless. It works everywhere in the universe. It works always, without pause or variation. It never stops. Over time, the weak force of gravity becomes irresistible. A tiny gravitational pull, sustained over millions or billions of years, can accumulate into tremendous effects. This perhaps the deepest lesson that gravity teaches us about the nature of forces and the structure of reality. Weakness combined with universality and time can produce effects as profound as strength applied directly. Gravity's true strength lies not in its power, but in its universality and its infinite reach. Every object attracts every other object. This simple fact, repeated across all objects in the universe, creates the structure of the cosmos. Gravity is weak, but it is everywhere. Gravity is constant, but it is relentless. Gravity is simple in its law, but it is profound in its effects. The universe is structured by gravity. The cosmos is held together by gravity. From the largest galaxy clusters to the smallest pebbles on the ground, everything is touched by gravity's influence. This concludes our exploration of gravity, the weakest and yet most omnipresent of the fundamental forces. We have traveled through many dimensions of gravity's influence. We have seen how it shapes your body from birth to death, influences your daily life in countless ways, drives the natural cycles that sustain life, and structures the cosmos itself. Gravity is the first invisible force controlling everything around you. It is weak, yet it is relentless. It is quiet, yet it is always present. It asks nothing of you, yet it shapes every moment of your existence. As you move through your day, remember that gravity is with you. Feel its presence. Notice how it pulls on your body. Observe how it shapes the world around you. Water flows downward because of gravity. Plants grow upward because of gravity. The sky above you remains above because gravity is holding everything in place. The stars shine in the night sky because gravity holds them together in galaxies and universe structures. Your existence, and the existence of everything you see, is ultimately made possible by gravity. It is the first of the 4 invisible forces. 3 more remain to be explored. Each is remarkable in its own way. Each reveals a different dimension of reality. But for now, we have gravity. Rest in the knowledge that you are held by an invisible force that has been at work for billions of years, that will continue to work for billions of years more, and that asks nothing in return but the simple fact that you have mass. The electromagnetic force is the second of these invisible forces, and it is vastly more powerful than gravity on small scales. While gravity is content to work slowly, accumulating its effects over billions of years, the electromagnetic force acts with immediate and dramatic intensity. It is responsible for nearly every phenomenon you experience in your daily life, yet you remain mostly unaware of its presence. The electromagnetic force is the reason atoms bond together to form molecules. It is the reason materials have the properties they do. It is the reason light exists. It is the reason you can see anything at all. In a very real sense, the electromagnetic force is more directly responsible for the world you inhabit than gravity is. Gravity shapes the large-scale structure of the cosmos, but electromagnetism shapes everything in between, from the atom to the molecule, to the cell, to the living organism. It is vastly more powerful than gravity, approximately a septillion times stronger at atomic scales, yet it goes mostly unnoticed because its effects are so intimate and familiar that we take them completely for granted. The electromagnetic force acts on charged particles, causing opposite charges to attract and like charges to repel. This simple rule, this basic fact about how charged particles interact, generates nearly all the complexity you see around you. The electromagnetic force has infinite range, like gravity, but it can attract or repel, making it far more versatile and capable of creating intricate patterns of interaction. Where gravity can only pull, electromagnetism can push and pull, creating the dynamic complexity that allows atoms to bond, molecules to form, and chemistry to exist. Consider the electromagnetic force for a moment. Think about what would happen if it did not exist. Without electromagnetism, there would be no atoms as you know them. Electrons would not be bound to nuclei. Electrons would not orbit atoms. Matter as you know it could not form. There would be no chemistry, no biology, no life. The sun would not shine because the nuclear fusion reactions that power it depend on electromagnetism. Without the electromagnetic force, there would be no light, no heat radiating from stars, no photosynthesis, no food chains, no ecosystems. The electromagnetic force is actually more fundamental to life on Earth than gravity is, though gravity gets more of the attention. The electromagnetic force is responsible for light traveling across space. Light is an electromagnetic wave, a ripple in the electromagnetic field that propagates at the speed of light. Every photon of light, every particle of light energy that has ever touched your eyes is a manifestation of the electromagnetic force. The electromagnetic force makes it possible for you to see. The electromagnetic force is responsible for all chemistry. Chemical bonds form because electrons are attracted to nuclei through electromagnetic force. When atoms come together, their electrons interact with the electromagnetic fields of surrounding nuclei. Electrons move to configurations that minimize energy, creating bonds between atoms. These bonds are purely electromagnetic in nature. When you mix two chemicals and they react, the reaction is driven by electromagnetic interactions between electrons and nuclei. Atoms rearrange themselves to reach lower energy states. Energy is released as the reaction proceeds. When you eat food, and your body digests it. The breaking down of molecules and the release of energy is all electromagnetic in nature. Enzymes in your digestive system use electromagnetic forces to break chemical bonds. Nutrients are absorbed through electromagnetic interactions between molecules in your intestinal lining. When your cells use glucose for energy, they do so through a cascade of chemical reactions driven entirely by electromagnetism. Every single biological process in your body that involves molecules interacting is fundamentally driven by electromagnetism. Your muscles contract through electromagnetic forces. Your nerves fire through the movement of charged ions driven by electromagnetism. Your genes express themselves through electromagnetic interactions between proteins and DNA. Life itself is electromagnetic in nature. Your smartphone is a device entirely powered by electromagnetic force. When you hold your phone in your hand, you are holding an object that works through the interaction of billions upon billions of charged particles. The battery in your phone uses electromagnetic interactions to create electrical current. The circuits in your phone guide this current through pathways. The screen displays images because billions of tiny dots emit light through electromagnetic interactions. The speakers produce sound because electromagnetic coils vibrate to push air. The microphone captures sound because vibrating air moves a membrane that changes the electromagnetic field. Every function your phone performs, from the simplest to the most complex, is enabled by electromagnetic force. And yet you probably do not think about electromagnetism when you use your phone. You think about the tasks you are accomplishing, the people you are communicating with, the information you are accessing. The electromagnetic force is invisible, running quietly in the background, making everything possible. Wireless charging represents one of the most direct applications of electromagnetic force in modern life. When you place your phone on a wireless charger, you are watching electromagnetic induction at work. The charger creates a changing magnetic field. This magnetic field passes through the air and through the case of your phone. It induces an electrical current in a coil inside your phone. This current charges the battery. No wires are needed. No metal contacts must touch. Energy is transferred invisibly through the air via electromagnetic fields. This would have seemed like magic a century ago. Someone from the 19th century would have called it impossible. Yet it is simply electromagnetism working in a particular way, inducing currents without direct contact. The same principle powers many technologies. Induction cooktops use electromagnetic induction to heat cookware. When you turn on an electric light, you are completing a circuit that allows electrical current to flow through a bulb. The current interacts with the material in the bulb to produce light. When you turn on your television, electromagnetic signals travel through the air or through cables to your device, creating the images you see on the screen. Every electrical appliance in your home runs on electromagnetic force. Your refrigerator uses electromagnetic coils to compress refrigerant, cooling your food. Your washing machine uses electromagnetic fields to control water flow and spin the drum. Your oven heats through electromagnetic resistance when electrical current flows through heating elements. Your dishwasher, your microwave, your vacuum cleaner, your hairdryer, all of these devices work through electromagnetic interactions. It is almost impossible to find an electrical appliance that does not rely on electromagnetism in multiple ways. The simple light bulb is powered by electromagnetic current flowing through a filament. The electric motor that drives fans, pumps, and compressors in countless appliances uses electromagnetic force to convert electrical energy into motion. When an electrical current flows through a coil in a magnetic field, the coil rotates. This is the principle behind every electric motor. Your car starter motor is an electric motor. Your food blender has a small electric motor that spins the blades. Your computer has cooling fans driven by electric motors. The principle is the same in all of them. Electromagnetic force converts electrical current into mechanical motion. Static electricity is perhaps the most immediate and personal way you can experience electromagnetic force directly. You have felt static electricity many times without thinking about it. Rub a balloon against your hair and the balloon sticks to your head. This is static electricity. When you shuffle your feet across a carpet and then touch a metal doorknob, a spark jumps between your hand and the doorknob. This is static electricity discharging. The experience is immediate. You can feel it. You can see it. This is electromagnetic force made visible and tangible. When you rub a balloon against your hair, electrons transfer from your hair to the balloon. Your hair loses electrons, becoming positively charged. The balloon gains electrons, becoming negatively charged. Now the two are opposite. Lie charged, and opposite charges attract. Your hair is attracted to the balloon. The strands of your hair cling to the balloon and stick up because they are being pulled toward it. The force between your charged hair and the charged balloon is strong enough to overcome gravity. The electromagnetic force is overpowering gravity in this simple experiment. A tiny amount of transferred electrons creates a force strong enough to defy the entire gravitational pull of the Earth. This is a dramatic demonstration of how much more powerful electromagnetism is than gravity. Magnetism is the other face of the electromagnetic force. Magnets are everywhere in your home. You have magnets on your refrigerator. You probably did not think about why magnets stick to your refrigerator, but it is electromagnetic force at work. The magnet creates a magnetic field. The field extends outward from the magnet. When the field encounters the iron in the refrigerator door, it exerts a force on the iron atoms. The iron atoms have electrons that interact with the magnetic field. The interaction is attractive, pulling the magnet toward the iron and the iron toward the magnet. The magnet clings to your refrigerator because electromagnetic force is pulling them together. Refrigerators use magnetic seals around their doors. This seal is a rubber gasket with magnets embedded in it. When the door closes, the magnets attract to metal on the refrigerator frame, creating a tight seal that prevents cold air from leaking out. Without this magnetic seal, cold air would leak out continuously. Your food would spoil faster. Your refrigerator would have to work constantly to maintain the proper temperature. Magnetic seals are so effective and efficient that modern refrigerators depend on them. A simple application of electromagnetic force keeps your food fresh. Medical imaging technology like MRI machines represents one of the most sophisticated applications of electromagnetic force in human medicine. An MRI scanner creates an incredibly strong magnetic field, far stronger than any magnet you encounter in daily life. This magnetic field is powerful enough to align the nuclei of hydrogen atoms in your body. Hydrogen is everywhere in your body because you are mostly water and biological molecules. When these nuclei align in the magnetic field, they absorb radio waves broadcast at a specific frequency. When the radio waves are turned off, the nuclei emit signals as they relax back to their normal state. Sensitive receivers detect these signals and computers create detailed images of the inside of your body. This is entirely non-invasive. No radiatio. N is used. No surgery is required. The electromagnetic force allows doctors to see inside the human body without cutting it open. MRI scans can detect cancers, brain injuries, tissue damage, and countless other conditions. The technology saves lives every single day. Children being scanned in MRI machines are being examined by electromagnetic force, guided by scientific principles developed over the past century. Wireless communication is one of the most remarkable applications of electromagnetic force in the modern world. When you use Wi-Fi, you are using invisible electromagnetic waves to transmit data. Your router broadcasts electromagnetic waves at a specific frequency. Your device receives these waves and converts them back into data. The waves travel through the air, through walls, through windows. They pass right through your body as you move about. You do not feel them because they are electromagnetic waves, not material objects. Think about that for a moment. Right now, as you read this, invisible waves are passing through your body. Radio signals from broadcasts are going through you. Wi-Fi signals are going through you. Cellular signals are going through you. These waves encounter the atom, S, in your body and pass through without causing harm, because they have very low energy. Radio waves, microwave radiation, and visible light are all electromagnetic waves. They differ only in their frequency and wavelength. Radio waves have long wavelengths and low frequency. Visible light has short wavelengths and high frequency. Gamma rays have even shorter wavelengths and higher frequency. But they are all electromagnetic waves, all manifestations of the same electromagnetic force. Your cellular phone uses radio waves to communicate with cell towers. Your satellite television receives electromagnetic waves broadcast from satellites in orbit. Your AM and FM radio receives radio waves transmitted from radio stations. Your Bluetooth devices use radio waves to communicate with each other. Your Wi-Fi network uses a specific radio frequency to transmit data at high speed. All of these wireless technologies depend on electromagnetic waves traveling through the air at the speed of light. The fact that you can talk to someone on the opposite side of the world instantly through a wireless device is a testament to the power of electromagnetic force. The communication happens at the speed of light because electromagnetic waves travel at light speed. There is no faster communication possible. Light speed is the ultimate speed limit in the universe, and electromagnetic waves travel at this maximum velocity. The weak nuclear force is the third of these fundamental forces, and it is a strange and subtle force that operates only at the incredibly tiny scale of atomic nuclei. You have never experienced the weak nuclear force directly. You will never encounter it in your daily life. Yet it is absolutely essential for your existence. The weak force is responsible for radioactive decay. When certain atomic nuclei are unstable, they decay through a process called beta decay. In beta decay, a neutron transforms into a proton. This transformation releases an electron and an antineutrino. The electron is ejected at high speed from the nucleus. This ejected electron is what scientists used to call beta radiation. The transformation happens because the weak force causes one of the quarks inside the neutron, N, to change its character. A down quark changes into an up quark. This simple transformation releases energy and changes the nucleus. The weak force is the only force that can cause quarks to change flavor. It is unique in this ability. No other force can transform one type of quark into another. Only the weak force has this remarkable property. This means that the weak force alone is responsible for changing the identity of particles at the most fundamental level. The weak force is weaker than the electromagnetic force and the strong force, but it is stronger than gravity. It operates only at extremely short ranges. Beyond the scale of an atomic nucleus, the weak force effectively does not exist. Its range is about 1,000th the diameter of a proton. This extremely short range is why you never experience the weak force directly. You are far too large. The atoms in your body are far too large. Even your cells are far too large. Only at the scale of subatomic particles does the weak force become relevant. Yet at that scale, the weak force is crucial. The weak force drives nuclear fusion in the Sun. In the core of the Sun, protons collide at incredible speeds and temperatures. When two protons collide, they can fuse together, combining into a new nucleus. This process requires the weak force. It is the weak force that allows protons to transform into the nuclei of heavier elements. As this happens, energy is released. This energy is what makes the Sun shine. Without the weak force, the Sun could not undergo fusion. Without fusion, there would be no sunlight. Without sunlight, there would be no photosynthesis. Without photosynthesis, there would be no food chains. Without food chains, there would be no animals. Without animals, there would be no people. Your existence depends entirely on the weak force making the Sun shine. Radioactive decay is the primary way we observe the weak force at work in the universe. Certain atoms are unstable. When these atoms decay, they release energy and particles. This happens because the weak force causes the nucleus to transform into a different configuration. Some decays happen almost instantaneously, in fractions of a second. Others take millions of years to complete. Some isotopes have half-lives of billions of years. Scientists have discovered that radioactive isotopes decay at predictable rates. This property allows us to use radioactive dating to determine the age of rocks and fossils. We measure how much of a radioactive isotope remains in a sample and calculate how long it has been decaying. This technique has revealed that the Earth is about 4.5 billion years old. Radioactivity driven by the weak force has allowed us to rewrite the history of the planet. Without radioactive dating, we would have no accurate way to know how old the Earth is. The heat from radioactive decay inside the Earth powers plate tectonics and volcanism. Deep within the Earth, radioactive elements are slowly decaying. This decay releases heat. This heat keeps the interior of the Earth hot and molten. This heat drives the movement of tectonic plates. Earthquakes occur because of plate tectonics. Volcanoes erupt because of the heat from radioactive decay in the Earth's mantle. The landscape you see around you, the mountains and valleys, the ongoing evolution of continents, is all driven partly by radioactive decay. The weak force is literally shaping the planet beneath your feet through radioactive heat. The strong nuclear force is the fourth and final of the fundamental forces. It is by far the most powerful force in nature, approximately a septillion times stronger than gravity at the scale where it operates. The strong force is the force that holds atomic nuclei together. It binds quarks together into protons and neutrons. It binds protons and neutrons together into nuclei. Without the strong force, matter as you know it could not exist. There would be only hydrogen. No elements heavier than hydrogen could form. The diversity of chemistry, the existence of carbon and oxygen and iron and all the other elements depends on the strong force. Quarks are the fundamental building blocks of matter. They come in different varieties or flavors. There are up quarks and down quarks, charm quarks and strange quarks, top quarks and bottom quarks. A proton contains 2 up quarks and 1 down quark. A neutron contains 1 up quark and 2 down quarks. These quarks are permanently bound together by the strong force. You cannot pull quarks apart. No matter how much energy you apply, you cannot isolate a single quark. If you try to pull 2 quarks apart from a proton, the energy required is so enormous that it creates new quark-antiquark pairs. As you pull the quarks farther apart, the energy increases. At some point, this energy becomes great enough to create new particles. Instead of getting 2 separate quarks, you get new quarks and antiquarks. The quarks at the ends of this string are pulled together by the strong force, forming new bound states. In this way, quarks are permanently imprisoned inside particles. We have never observed a free quark in the entire history of particle physics. We likely never will. Quarks are prisoners of the strong force, forever bound to other quarks. This is a remarkable property of the strong force, unlike any other force in nature. It means that the most fundamental constituents of matter cannot exist in isolation. The strong force solves a fundamental problem in physics. Inside the nucleus of an atom, multiple protons are crammed together in an incredibly tiny space. Each proton has a positive electrical charge. Positive charges repel each other. The electromagnetic force pushes protons away from each other with tremendous force. Yet somehow protons remain bound in the nucleus. They do not fly apart. The reason is the strong force. The strong force is even more powerful than the electromagnetic repulsion. It overcomes the repulsion and binds the protons together. If the strong force were even slightly weaker, atomic nuclei would fly apart. No atoms except hydrogen could exist. If the strong force were even slightly stronger, the universe might be very different. Protons might bind so tightly that no chemistry could occur. The exact strength of the strong force is finely tuned to allow the existence of complex atoms and chemistry. The strong force is carried by particles called gluons. Gluons mediate the strong force between quarks. The name gluon perfectly captures their function. They act like glue, holding quarks together. Gluons are strange particles, unlike photons, which carry the electromagnetic force and have no mass. Gluons carry a property called color charge. The term color is just a label. It has nothing to do with actual color. Physicists use red, green, and blue to label the three types of color charge. There are also anticolors. The interaction is described by a theory called quantum chromodynamics, which is beautiful and complex and reveals the deep structure of matter. The strong force operates only at incredibly short ranges. It stops working when particles are even a tiny distance apart. The range of the strong force is about 100,000 times smaller than the diameter of an atom. This is why we never directly experience the strong force in daily life. It is confined to the interior of atomic nuclei. Its effects are hidden from view, yet at the scale where it operates, the strong force is absolutely dominant. It is the fundamental force that determines the structure of atoms, and therefore the structure of all matter. Most of the mass of a proton comes not from the quarks themselves, but from the energy of the strong force binding them together. The quarks provide only about 1% of the proton's mass. 99% of the proton's mass is frozen strong force energy. This is a profound and counterintuitive fact. Nearly all the mass of your body does not come from the substance of quarks and electrons. It comes from the energy bound up in the strong force holding atoms together. You are mostly strong force energy. The entire universe is mostly strong force energy. About 98% of all the mass in the visible universe is due to the strong force. The remaining 2% comes from the intrinsic masses of quarks and electrons. The dream of physicists since the time of Einstein has been to unify all four fundamental forces into a single comprehensive theory. If all forces could be revealed as different aspects of one underlying force, it would represent a profound simplification of nature. It would suggest that beneath the apparent diversity of forces lies a single elegant principle. Scientists have made progress toward this goal. The greatest success so far is the electroweak unification. In the 1960s, physicists Sheldon Glashow, Abdus Salam, and Steven Weinberg developed a theory showing that the electromagnetic force and the weak nuclear force are actually different aspects of a single underlying electroweak force. These forces appear completely different at the temperatures and energies we experience every day. But at incredibly high temperatures, they merge into a single force. At the incredibly high temperatures that existed in the first fraction of a second after the Big Bang, these two forces were unified into one. As the universe expanded and cooled, the symmetry broke and the forces separated into the distinct phenomena we observe today. This was like a phase transition, similar to water freezing into ice or evaporating into steam, but happening with the forces themselves. This unification was so important that Glashow, Salam, and Weinberg received the Nobel Prize in 1979 for this theoretical work. Later experiments confirmed the predictions of this unified theory, validating one of the greatest intellectual achievements of modern physics. Building on the success of electroweak unification, physicists have proposed grand unified theories that attempt to unify three of the four fundamental forces. These theories suggest that at even higher energies than required for electroweak unification, the strong force also unifies with the electroweak force. This would have occurred in the first infinitesimal fraction of a second after the Big Bang, when the universe was unimaginably hot and dense. As the universe expanded and cooled, the strong force separated from the electroweak force. The electroweak force then separated into electromagnetic and weak forces as the universe continued to cool. This gives us a picture of the early universe in which all forces except gravity were unified. Some physicists speculate that even gravity might unify with the other forces at energies far higher than we can currently achieve. This is the dream of a theory of everything, a single unified principle from which all forces and all particles emerge. The most complete understanding of the four fundamental forces comes from quantum field theory, the framework that describes how particles and forces interact. In quantum field theory, each force is described by a field that permeates all of space. Particles are excitations in these fields. When an electron absorbs a photon, it is absorbing energy from the electromagnetic field. When two quarks exchange a gluon, they are exchanging energy from the strong force field. The universe is made of fields, and particles are ripples and excitations in these fields. Forces arise from interactions between fields. This view of reality is profound and elegant, yet it remains incomplete. We do not have a quantum field theory that includes gravity. Gravity remains separate from the quantum description of the other forces. Finding a way to unify gravity with the other forces in a quantum framework is one of the greatest unsolved problems in physics. The observable universe is structured by these four forces in intricate ways. Gravity shapes the large-scale structure, holding galaxies together and shaping cosmic evolution. Electromagnetism binds atoms together and creates chemistry and light. The weak force powers stars through nuclear fusion and shapes the composition of atoms through radioactive decay. The strong force holds atomic nuclei together and allows atoms to exist. These four forces, operating at different scales and with different strengths, create the universe of extraordinary complexity and diversity you see around you. They operate invisibly, never asking for recognition, yet they are absolutely fundamental to your existence. Every atom in your body is held together by these forces. Every thought in your head arises from electromagnetic interactions in your brain. Every breath you take, every heartbeat, every moment of consciousness depends on the four fundamental forces working in concert. You are made of invisible forces. The universe is made of invisible forces. And now you know what they are. These forces are not separate or isolated from each other. They interact in subtle and profound ways. The unification of forces suggests that at the deepest level, there is only one force, manifesting in different ways at different scales and temperatures. The history of physics has been a history of recognizing underlying unity beneath apparent diversity. Newton showed that the force that makes an apple fall is the same force that holds the moon in orbit. Maxwell showed that electricity and magnetism are two aspects of the same electromagnetic force. Modern physicists have shown that electromagnetism and the weak force are two aspects of the electro-weak force. The pattern continues. There may be a grand unified force underlying all four fundamental forces. This is the dream that drives physics forward. This is the hope that underneath the apparent chaos and complexity of the universe lies profound simplicity and unity. As you move through your day, remember that you are surrounded by invisible forces. Gravity pulls on you constantly, holding you to the earth and shaping your every movement. Electromagnetic forces bind your atoms together and allow you to see and think and feel. Every sensation, every thought, every moment of awareness is electromagnetic in nature. The weak force powers the sun that warms your world and makes life possible. The strong force holds the nuclei of atoms together, preventing matter from falling apart. These forces are not metaphors or abstractions. They are real. They are present. They shape every moment of your existence. You cannot see them, but they are there. You cannot feel them directly, except through their effects. Yet their effects are everywhere, in everything, at every moment. The four fundamental forces are the deepest laws of nature we have yet discovered. They may not be the deepest laws that exist, but they are the deepest we currently understand. And understanding them gives you a glimpse into the true structure of reality beneath the surface of the world. You now know what holds the universe together. You now know what makes life possible. You now know the 4 invisible forces controlling everything around you. This would have occurred in the first infinitesimal fraction of a second after the Big Bang, when the universe was unimaginably hot and dense. As the universe expanded and cooled, the strong force separated from the electroweak force. The electroweak force then separated into electromagnetic and weak forces as the universe continued to cool. This gives us a picture of the early universe in which all forces except gravity were unified. Some physicists speculate that even gravity might unify with the other forces at energies far higher than we can currently achieve. This is the dream of a theory of everything, a single unified principle from which all forces and all particles emerge. The most complete understanding of the 4 fundamental forces comes from quantum field theory, the framework that describes how particles and forces interact. In quantum field theory, each force is described by a field that permeates all of space. Particles are excitations in these fields. When an electron absorbs a photon, it is absorbing energy from the electromagnetic field. When 2 quarks exchange a gluon, they are exchanging energy from the strong force field. The universe is made of fields, and particles are ripples and excitations in these fields. Forces arise from interactions between fields. This view of reality is profound and elegant, yet it remains incomplete. We do not have a quantum field theory that includes gravity. Gravity remains separate from the quantum description of the other forces. Finding a way to unify gravity with the other forces in a quantum framework is one of the greatest unsolved problems in physics. The observable universe is structured by these 4 forces in intricate ways. Gravity shapes the large-scale structure, holding galaxies together and shaping cosmic evolution. Electromagnetism binds atoms together and creates chemistry and light. The weak force powers stars through nuclear fusion and shapes the composition of atoms through radioactive decay. The strong force holds atomic nuclei together and allows atoms to exist. These 4 forces, operating at different scales and with different strengths, create the universe of extraordinary complexity and diversity you see around you. They operate invisibly, never asking for recognition, yet they are absolutely fundamental to your existence. Every atom in your body is held together by these forces. Every thought in your head arises from electromagnetic interactions in your brain. Every breath you take, every heartbeat, every moment of consciousness depends on the 4 fundamental forces working in concert. Think about the moment you wake up in the morning. Your eyes open because gravity holds you to the bed and muscles must overcome that pull. Gravity has shaped your body overnight, compressing your spine slightly as you slept. Throughout the night, your heart continued beating because of electromagnetic interactions controlling muscle contractions. Your neurons fired because of weak electromagnetic interactions between ion channels. Your cells produced energy through chemical reactions powered by electromagnetic bonds. You have not experienced a single moment of your life free from these forces. They are woven into every instant of awareness. You are not separate from these forces. You are a product of them. Your consciousness itself emerges from the dance of electromagnetic interactions among billions of neurons. Your thoughts are electromagnetic events. Your memories are electromagnetic patterns. Your personality is electromagnetic structure. When you touch something, you feel the electromagnetic repulsion between the electrons in your hand and the electrons in the object. You are not actually touching anything. There is a gap between your skin and the object. The electromagnetic force keeps you from passing through solid matter. This is why objects feel solid even though they are mostly empty space. The electrons in the outer shells of atoms repel each other, creating the sensation of solidity. Without electromagnetism, you could pass through walls. Without gravity, you would float away. Without the weak force, the sun would not shine. Without the strong force, atoms would not exist. Your physical existence depends entirely on these four forces working in perfect balance. The balance between forces is extraordinarily precise. If gravity were slightly stronger, stars would burn too quickly, ending after only a few million years instead of billions. Planets would not form. Life would not have time to evolve. If gravity was slightly weaker, stars would never ignite. Cold, dark planets would orbit forever around dead stars that never achieved fusion. If the strong force was slightly weaker, protons would decay and atoms would fall apart. If the strong force was slightly stronger, the universe would contain no hydrogen, only heavy elements bound together so tightly that chemistry could not occur. The electromagnetic force must be exactly the strength it is, or atoms could not form. The weak force must be weak enough to allow the sun to shine slowly, but strong enough to occur at all. The universe we observe appears to be finely tuned for the existence of chemistry, stars, planets, and life. Small changes to any of these forces would result in a sterile, lifeless universe, incapable of supporting complexity. This fine-tuning has led some physicists to consider the anthropic principle. This principle suggests that we observe the universe to have the particular properties it does because we could only exist in a universe with these properties. If the forces were different, we would not be here to observe it. In other words, we should expect to find ourselves in a universe fine-tuned for life because we could not exist otherwise. This perspective shifts how we think about the apparent improbability of our universe's constants. It is not that the forces happen to be precisely balanced by incredible luck. Rather, we could only observe universes that are balanced this way. Other universes with different force strengths might exist, but they contain no observers. We can only observe universes like ours. The search for unification continues to drive modern physics forward. Physicists today work on string theory, loop quantum gravity, and other frameworks that attempt to reconcile quantum mechanics with general relativity and unify all four forces. These theories propose that at the smallest scales, particles are not points but tiny vibrating strings. Different vibration patterns correspond to different particles. The forces arise from the geometry of extra dimensions curled up so tightly they are invisible. These ideas remain speculative and await experimental confirmation. None of them have gained universal acceptance, yet they represent humanity's best attempts to understand the deepest structure of reality. The implications of a unified theory would be staggering. If a single force underlies all four forces, then we would understand the universe in a fundamentally different way. We would see that apparent diversity masks deeper unity. Gravity would emerge from the same principle as the strong force. Light would be revealed as the same phenomenon as nuclear reactions. Chemistry would be understood as a special case of something more fundamental. The universe would appear less complicated and more elegant. It would suggest that nature, at its core, follows simple, beautiful principles that manifest as apparent complexity at the scales we observe. This is the dream that keeps physicists working, even when experiments become incredibly difficult and expensive. Unification would reveal that the seeming independence of forces is an illusion created by the universe's current cool state. Just as solid ice and flowing water are both manifestations of water molecules, the different forces are manifestations of a single underlying principle. The beautiful aspect of unification is that it requires no new assumptions about nature. Instead, it reveals that assumptions we already make are more deeply unified than we realized. It takes concepts we already understand and shows them to be part of a larger pattern. When Maxwell unified electricity and magnetism, he did not need to invent new concepts. He showed that electricity and magnetism were different aspects of electromagnetism. Similarly, unified theories of the fundamental forces are not inventing new forces. They are showing that forces we already know about have a deeper unity. This is the pattern in physics. Complexity simplifies when you look at it the right way. Experiments attempting to discover unification require enormous energies. The more unified the forces become, the higher the energies required to observe the unification directly. The Large Hadron Collider, the world's most powerful particle accelerator, smashes protons together at nearly the speed of light to create conditions that briefly existed moments after the Big Bang. Even this incredible instrument has not detected direct evidence of unification beyond what we already know from the electroweak unification. To test some unified theories would require an accelerator the size of a galaxy. Future experiments may be impossible with any technology we could build. This creates a paradox for fundamental physics. The deeper truths may be inaccessible to direct experimental observation, yet there may be indirect ways to detect unification. Some unified theories predict that protons decay. This decay would happen so rarely that detecting even a few decays would take detectors filled with millions of tons of material watched for years. So far, experiments searching for proton decay have found nothing. This does not disprove unification, but it constrains which theories are viable. Other theories predict new particles or forces that might be observed indirectly through subtle deviations in precision measurements. As experiments become more precise, they may reveal hints of new physics hiding just beyond current energy ranges. The concept of spontaneous symmetry breaking is crucial to understanding how unified forces become distinct as the universe cools. In quantum field theory, a symmetry can be exact in the equations describing a system yet be broken in the actual state of that system. Consider a pencil balanced perfectly on its point. The system has rotational symmetry around the vertical axis, yet if you disturb the pencil even slightly, it falls over, breaking the symmetry. The equations describing the pencil retain the symmetry even though the actual pencil does not. This is spontaneous symmetry breaking. In the early universe, the electroweak force equations had perfect symmetry, yet the actual state of the universe broke that symmetry. As the universe cooled, the Higgs field acquired a non-zero value throughout space. This broken symmetry allowed different particles to acquire different masses. It allowed the electromagnetic force to separate from the weak force. The same mechanism applies to grand unification and any further unification with gravity. The mathematical symmetries are exact, but the state of the universe breaks them. The energy at which unification might occur is enormous. It is called the Planck energy, approximately 1 trillion times higher than the energy available at the Large Hadron Collider. At this energy, the strong force, electromagnetic force, and weak force would all have equal strength. Gravity would become strong and would need to be included in the unified description. This is a regime we can never directly probe experimentally, yet physicists can think about what happens at these energies using mathematical frameworks. String theory suggests that at Planck energies, strings become comparable in size to black holes, and space-time itself might dissolve into a foam of quantum fluctuations. The history of unification in physics shows a clear pattern. As science progresses, forces that seemed separate turn out to be related or identical. Electricity and magnetism seemed completely different until Maxwell unified them. The sun shines because the weak force exists, yet for centuries nobody suspected these were connected. Electromagnetism and the weak force seemed utterly different until Glashow, Salam, and Weinberg unified them. This history suggests that gravity might also be unified with the other forces, even though such unification remains elusive. Each time a unification is achieved, our understanding deepens and we see further into nature's structure. The unification of forces has practical implications. The electroweak unification predicted new particles called W and Z bosons. When experiments detected these particles at exactly the energies predicted by unified theory, it provided confirmation of a profound truth about nature. These experiments required incredible precision and sensitivity. Physicists had to cool particles to near absolute zero, detect individual decay events among trillions of collisions, and reconstruct events that lasted only fractions of a second. The successful detection of predicted particles was a triumph of both theoretical and experimental physics. It showed that mathematics describing nature at scales far beyond direct observation could make predictions that experiments could verify. The practical benefits of fundamental physics research are often not immediately obvious. Electricity and magnetism were unified in the 19th century with no thought to practical application. Yet this unification led to radio, television, radar, and ultimately wireless communication. The discovery of radioactivity and the weak force seemed purely academic. Yet nuclear medicine, which saves millions of lives, depends on understanding radioactive decay. Quantum mechanics emerged from theoretical physics with no practical application in mind. Yet quantum mechanics is essential for understanding semiconductors, lasers, and all modern electronics. Fundamental physics research often leads to technologies we cannot yet imagine. The search for unification may ultimately lead to capabilities we cannot currently conceive. Energy considerations become crucial when understanding how unified theories work. At the incredibly high temperatures of the early universe, the distinctions between forces dissolve. Forces that seem completely different at everyday energies become identical at high energies. This is similar to how ice, water, and steam are all the same substance in different states. Water freezes into ice because energy decreases. Water evaporates into steam when energy increases. These are not three different things, but manifestations of a single thing in different energy regimes. The forces behave similarly. At high energies, they merge. At low energies, they separate. The universe we observe is the low-energy state of a more fundamental theory. The cooling of the universe is not a matter of temperature changing while everything else stays the same. As the universe expanded and cooled after the Big Bang, phase transitions occurred. These transitions changed the fundamental nature of reality. The first transitions separated the strong force from the electroweak force. This happened a fraction of a second after the Big Bang. Later, as temperatures fell further, the electroweak force separated into electromagnetic and weak forces. These transitions changed not just the force strengths but the very structure of particles and fields. At the moment of each transition, the universe changed in ways that made certain particles possible and made other particles impossible. Our existence depends on these transitions happening in precisely the right way. Had the electroweak transition occurred even slightly differently, the symmetry between electrons and neutrinos might have been broken differently. This would have changed the rates at which nuclear reactions occur. It would have changed the amounts of different elements produced in the early universe. It would have changed which stars could form and which planets could exist. Every detail of cosmic evolution depends sensitively on how these transitions unfolded. We exist because the forces separated in the particular way they did. Symmetry is a central concept in understanding forces. The electromagnetic force has a symmetry. If you flip all charges from positive to negative and back again, the electromagnetic force looks the same. This symmetry principle is called charge symmetry. The weak force has different symmetries, and these symmetries constrain how the weak force can work. Unified theories require new symmetries that encompass both the weak force and the strong force. These symmetries are more complex than the symmetries of individual forces. They require more mathematics to describe. Yet once these symmetries are understood, the forces become unified. Symmetry is the language in which nature speaks at the deepest level. In mathematics, symmetries are described using group theory, a branch of mathematics that studies transformations. A symmetry group is the set of all transformations that leave something unchanged. For example, a square has rotational symmetries. If you rotate it by 90 degrees, it looks the same. If you rotate it by 180 degrees, it looks the same. These rotations form a symmetry group. The electromagnetic force has a symmetry group called the special unitary group, SU of 2 dimensions. When these forces are unified into the electroweak force, they share a symmetry group called the SU of 2 times U of 1. This mathematical structure is what determines how the force behaves. The particulars are classified according to how they transform under these symmetries. Understanding the symmetries allows physicists to predict which particles should exist and how they should interact. The standard model of particle physics is built entirely on symmetry principles. It describes the strong force, the weak force, and the electromagnetic force using symmetry groups. The only force not included is gravity. The standard model is extraordinarily successful. It has made thousands of predictions that have all been confirmed experimentally. Yet it is incomplete. It does not include gravity. It does not explain why the forces have the particular strengths they do. It does not explain why particles have the masses they do. These are the mysteries that drive physicists to seek beyond the standard model. The next level of unification would address these mysteries. Broken symmetries are crucial to understanding the universe. Early in the universe, more symmetries existed. As the universe cooled, these symmetries broke. Some symmetries are exact at high energies and only broken at low energies. This is what happened with the electroweak unification. Other symmetries are only approximate. For example, the strong force has a symmetry called flavor symmetry that is approximate. This symmetry explains why quarks come in different flavors yet behave similarly. The breaking of symmetries as energy decreases explains why the universe looks so different at different energy scales. It explains why the forces appear separate at low energies even though they unify at high energies. Higgs boson discovery in 2012 provided the first direct evidence for how electroweak symmetry breaks. The Higgs boson is a particle associated with a field that permeates all of space. At high energies, this field has a particular value that respects the electroweak symmetry. At lower energies, the field shifts to a different value. This shift breaks the symmetry. As a result of this broken symmetry, particles acquire mass and the electromagnetic and weak forces become distinct. The Higgs boson is the quantum excitation of the Higgs field. Finding this particle experimentally provided confirmation that the mechanism by which electroweak symmetry breaks is correct. It was a remarkable validation of unified theory predictions. The mathematics describing unified forces is extraordinarily complex. Physicists must work with equations that have hundreds of terms. They must use sophisticated techniques from group theory, differential geometry, and quantum field theory. The calculations are performed by computers that run for hours or days. Yet from this complexity emerges a simple picture. At high energies, a single principle governs all interactions. The apparent complexity of the low-energy world emerges from symmetry breaking and the particular way spacetime is structured. This is the profound beauty of unification. Beyond the apparent chaos lies elegant order. The universe is fundamentally simpler than it appears. Consider what would happen if we could construct a particle accelerator powerful enough to probe the physics of unification. As we increase the collision energy, we would see particles behaving more and more similarly. The distinction between particles carrying different forces would blur. At the moment of unification energy, we would see forces merge. Particles that have different masses at low energy would become identical at high energy. The force strengths that differ at low energy would converge. The mathematics would simplify. Instead of 4 independent forces with 4 different coupling strengths, we would observe a single force with a single strength. This is what electroweak unification shows us, though at energies we can directly observe. The same principle would apply at high R unification energies, if we could reach them. The reason we cannot construct an accelerator powerful enough to observe grand unification directly is that the energies required are almost unimaginably large. The grand unification energy is estimated to be about 10 to the 16 giga-electron volts. The Large Hadron Collider reaches energies of about 14 teraelectron volts, which is only about 10 to the negative 2 of the required energy. To reach grand unification energy would require an accelerator with a circumference larger than our solar system. The technology to build such a device is completely beyond what humanity can currently conceive. This is one of the fundamental limitations of experimental physics. Some of the deepest truths may be experimentally inaccessible with any technology we could possibly build. Yet this does not diminish the value of seeking understanding. Sometimes the pursuit of knowledge is valuable in itself, independent of immediate practical benefit. Understanding the nature of the universe and our place within it may be the highest calling of human intelligence. The quest for unification is not driven by practical necessity. It is driven by intellectual curiosity and aesthetic principles. Physicists believe nature should be simple and elegant. They believe that if we look deep enough, we will find underlying unity. This belief has proven correct repeatedly throughout history. Each unification brought not just intellectual satisfaction, but also practical benefits. The belief in unification drives physicists to pursue research that has no immediate application, knowing from experience that fundamental understanding eventually yields practical fruit. Looking backward through history, we can trace how this belief in underlying unity has guided scientific progress. Newton unified terrestrial and celestial mechanics, showing that the same force responsible for falling apples holds the moon in orbit. This unification seemed impossible to his contemporaries. How could the heavy, solid earth and the ethereal heavens obey the same law? Yet Newton showed they did. This unification expanded humanity's understanding of the cosmos. Later, Maxwell unified electricity and magnetism. Again, these seemed like separate phenomena, but Maxwell showed they were two aspects of electromagnetism. Electricity can produce magnetism. Magnetism can produce electricity. This unification eventually led to the technologies of the Industrial Revolution. Every motor, every generator, every radio broadcast, every cell phone signal ultimately traces back to Maxwell's recognition of underlying unity. The discovery that light is an electromagnetic wave was another profound unification. For centuries, light seemed completely unrelated to electricity and magnetism. Yet Maxwell's equations predicted that electromagnetic waves should propagate at exactly the speed of light. This could not be coincidence. Light is an electromagnetic phenomenon. This unification expanded the electromagnetic spectrum beyond visible light to include radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. Each is simply electromagnetic radiation at different frequencies. This understanding opened entire new domains of technology and scientific investigation. Understanding how nature unifies apparently separate phenomena has consistently led to new knowledge and new capabilities. The implications for consciousness and awareness are profound, though still speculative. Your mind is a product of electromagnetic interactions among neurons. Your thoughts are electromagnetic events. Your memories are patterns encoded in the structure of neural connections. Your personality is the particular way your brain is organized. All of this depends on electromagnetism. But electromagnetism is part of a unified structure. If unification theories are correct, your consciousness emerges from one corner of a unified force structure that governs the entire universe. In a sense, your mind is a local manifestation of a universal principle. You are not separate from nature. You are nature observing itself through the particular organization of atoms and forces that is your brain. The chemical reactions happening in your brain right now as you process these words depend on all four forces. Gravity holds the molecules of your brain in place. Electromagnetic forces bind the atoms together and allow neural signals to propagate. The weak force ensures that your cells can produce energy through metabolism. The strong force holds the nuclei of your atoms together, making your physical brain possible. Remove any one of these forces, and your consciousness would cease to exist. The fact that you can contemplate the nature of forces is itself a product of those very forces. Consciousness emerged from forces, and consciousness can now study forces. This creates a strange loop. The universe created observers capable of understanding the universe. The forces created minds capable of discovering the forces. This circularity is one of the deepest mysteries in philosophy and science. Imagine a universe with only gravity and no other forces. Stars would collapse directly into black holes. No nuclear fusion would occur. No light would shine. No planets could form around stars. No chemistry could occur. Life would be impossible. This universe would be sterile and empty except for the slow, inevitable collapse of matter into black holes. Now imagine a universe with gravity and electromagnetism, but without the weak and strong forces. Atoms could form, but they would all be hydrogen. No nuclei heavier than a single proton could exist. No chemistry would occur beyond hydrogen chemistry. The periodic table would not exist. The complexity and variety that chemistry enables would be completely absent. Now imagine a universe with three forces, but lacking the strong force. Protons would repel each other due to their electromagnetic charge. No atomic nuclei could form. No atoms except the most exotic configurations would exist. Matter as we know it would not form. The universe would contain only particles without structure. Each successive force we remove makes the universe less capable of supporting complexity and ultimately life. This reveals how profoundly the four forces are tuned for the emergence of complexity. The four fundamental forces shape not just matter and energy, but the very possibility of complexity. A universe with different force strengths would not have stars, planets, chemistry, or life. Yet somehow the forces have exactly the values required for complexity to emerge. This appears to be either an incredible coincidence or evidence that the universe is fine-tuned for life. Either way, it is a remarkable fact. We exist in a universe where the forces are balanced just right. We might ask why this is true, but asking that question is asking why there is something rather than nothing. Physics describes how the universe works, but it does not fully answer why it exists at all. The study of the four fundamental forces represents the highest achievement of human intellectual endeavor. It required centuries of work by countless brilliant minds. It required the development of entirely new branches of mathematics. It required experiments of breathtaking complexity and precision. It required the construction of instruments of enormous size and cost. Yet through all this effort, patterns have emerged. We have glimpsed the deep structure underlying reality. We have moved from seeing four separate forces to recognizing that three of them unify. We have theoretical frameworks suggesting that all four might ultimately be unified. We have mathematical equations that describe with stunning accuracy how the universe behaves. This is humanity at its best, using reason and observation to pierce the veil of appearance and grasp reality beneath. These four forces binding everything together create order from what could be chaos. They create structure from constituent parts. They allow atoms to form, molecules to bond, cells to organize, organisms to live, and ecosystems to thrive. At every scale, from the smallest to the largest, these forces are at work. Gravity pulls galaxies together, binding the universe into structure. Electromagnetism creates the chemistry that allows life. The weak force powers the sun. The strong force holds matter together. These forces are not separate or independent. They interact, influence each other, and at the deepest level may be unified into one fundamental principle. The quest to understand and unify them continues, driven by the most profound questions humans can ask about reality. This quest has become the central endeavor of theoretical physics, and it will continue for generations to come. As you finish reading this exploration of the invisible forces, take a moment to reflect on what holds you together. Gravity pulls on every atom in your body. Electromagnetism binds your atoms and allows thought. The weak force, working in distant stars, powers the sun that warms your world. The strong force, operating in atomic nuclei, provides the substance of matter. These forces are as real as the chair you sit on, yet you cannot see them or touch them. They work invisibly, perpetually, binding the universe into the cosmos you observe. You are made of these forces. The universe is made of these forces. The deepest mystery physics has yet encountered is the possibility that all four are simply manifestations of one unified force, operating at different scales. Perhaps the journey of science is ultimately the journey toward recognizing this unity. Perhaps the universe has always been simpler and more elegant than it appears, and it is our understanding that gradually catches up to reality. In recognizing the unification of forces, we recognize that nature speaks in a unified language. Matter is unified. Forces are unified. Space and time may be unified. Everything may be unified. This unification does not diminish the wonder of existence. It deepens it. To understand that the universe operates according to elegant mathematical principles is to see the universe as even more remarkable than if it operated arbitrarily. This is the journey of understanding. This is the beauty of science. The invisible made visible through the power of human thought. The four forces that shape every moment of your existence remain hidden from direct perception. Yet, through mathematics and experimentation, through patient observation and bold theoretical leaps, humanity has discovered their existence and begun to understand their nature. This achievement of human intelligence stands as one of the greatest accomplishments of our species. We are made of stardust, shaped by ancient forces, capable of understanding those very forces. The circle completes. The universe creates observers capable of understanding the universe. The forces create minds capable of contemplating the forces. This is the deepest dialogue the universe can have, and you are part of it now. The quest continues in laboratories around the world, where physicists pursue the deepest mystery of existence. They work with machines of staggering complexity and cost, knowing that the answers they seek may lie forever beyond the reach of experimentation. String theory proposes that at the smallest scales of reality, particles are not points, but tiny vibrating strings, invisible even to our most powerful instruments. Different vibration patterns of these strings produce different particles. A string vibrating in one way becomes an electron. Vibrating in another way becomes a photon. The forces that seem so different at our scale emerge from the geometry of space itself. Extra dimensions, curled up so tightly that they remain forever hidden, influence how these strings vibrate and how they interact. In this framework, gravity is not fundamentally different from the other forces. It is simply the force that propagates through the extra dimensions we cannot perceive. If true, this would represent the deepest unification yet discovered. All forces would be revealed as manifestations of vibrating strings in multidimensional space. Yet string theory remains speculative. It has not made predictions that can be tested with current technology. It may take decades or centuries before anyone knows whether these ideas capture reality or represent a beautiful dead end in the history of physics. Loop quantum gravity takes a different approach. Instead of extra dimensions and vibrating strings, it reimagines space-time itself. At the smallest scales, space-time may not be smooth but granular, made of tiny loops woven together like fabric. These loops have a minimum size, below which space-time as we know it ceases to exist. In this picture, gravity emerges from the collective behavior of quantum loops and naturally unifies with other quantum forces. No extra dimensions needed. This approach appeals because it is economical and requires nothing beyond 4 dimensions, yet it remains unproven, with extraordinarily complex mathematics. The Large Hadron Collider near Geneva represents humanity's most ambitious attempt to probe the nature of forces at high energies. Two beams of protons travel in opposite directions around a circular tunnel 17 miles in circumference, accelerated to nearly the speed of light. When they collide, the energy released briefly recreates conditions that existed moments after the Big Bang. In those infinitesimal fractions of a second, particles are created that rarely exist in nature today. Instruments the size of buildings detect these particles and record their properties. Scientists analyze the data looking for hints of new physics, evidence of unified forces, or any phenomenon that contradicts the standard model. The discovery of the Higgs boson in 2012 validated the electroweak unifier, Chion, by confirming the existence of the particle responsible for breaking the symmetry between the electromagnetic and weak forces. This was a triumph of both theoretical prediction and experimental ingenuity. Yet despite years of searching, the collider has found no direct evidence of grand unification, no signs of supersymmetry, no hints of extra dimensions. This has surprised many physicists who thought such discoveries were imminent. Perhaps the forces do not unify in the way we imagined. Perhaps they unify at energies so high that we can never probe them. Perhaps we are asking the wrong questions. The more we study the forces, the more apparent it becomes that their constants have precise values required for complexity. If the strong nuclear force differed by just a few percent, no atoms heavier than helium could form. If the electromagnetic force was slightly stronger or weaker, atoms could not bind. The balance is precise. Some propose countless universes exist with different force strengths, and we inhabit one suited for life. Yet the multiverse remains speculative, beyond observation or testing. Others suggest the laws themselves may evolve as the universe evolves. Perhaps the forces were different in the past and will be different in the future. The structure of the cosmos is not static. Perhaps the forces do not remain constant either, and we exist in an era with particular values. The measurement of fundamental constants continues to be crucial in experimental physics. The fine structure constant, which characterizes the electromagnetic force, has been measured to remarkable precision. It equals approximately 1 divided by 137. No one knows why this value emerges from nature. It is a deep mystery. Physicists have proposed explanations ranging from information encoded in extra dimensions to random selection within ranges compatible with life. Neither is fully satisfying, yet both remain possible. The weak nuclear force constant differs from the electromagnetic constant by many orders of magnitude at low energies. Yet the electroweak theory predicts they converge at high energies. Experimental evidence confirms this convergence, providing powerful support for unification. Yet the convergence occurs at energies far beyond what any particle accelerator can achieve. At the grand unification energy, approximately 10 to the 16th gigaelectron volts, all three non-gravitational forces should converge to a single strength. Yet no accelerator can reach this energy. No technology we could possibly build could reach this energy. The largest conceivable accelerator, constructed from all the matter in our solar system, would still fall short. This creates a profound limitation in our ability to test unified theories. The most fundamental aspect of physics may be forever beyond experimental reach. Gravity presents the deepest problem. Unlike the other three forces, gravity has not been successfully integrated into the quantum framework. Quantum mechanics describes the other forces perfectly, making predictions accurate to many decimal places. Yet when physicists try to apply quantum mechanics to gravity, infinities appear in the calculations that cannot be removed. The math breaks down. The theory becomes nonsensical. This suggests that the current framework is incomplete. Something fundamental is missing from our understanding. General relativity, Einstein's geometric theory of gravity, works brilliantly at large scales. Quantum mechanics works brilliantly at small scales. Yet these two foundations of modern physics seem incompatible at the scales where both gravity and quantum effects are significant. Those scales exist nowhere in the observable universe, except perhaps in the centers of black holes and in the first fractions of a second after the Big Bang. Perhaps that is why we have not yet discovered how to unify them. The experiments would require destroying a black hole or traveling backward in time to the Big Bang. Yet physicists continue to pursue these unifications with remarkable dedication. String theory, loop quantum gravity, asymptotic safety, and dozens of other frameworks attempt to find the unified theory. Each has supporters and critics. Each can point to partial successes and unresolved problems. Each requires one to accept conclusions that seem strange or impossible. Yet history shows that reality is often stranger than our intuitions suggest. A century ago, physicists thought atoms were indivisible. Then they discovered electrons and nuclei. Then they discovered protons and neutrons. Then they discovered that protons and neutrons are made of quarks. Each level revealed deeper structure than anyone expected. Perhaps the next level of reality will be stranger still. Perhaps unified forces will reveal that space and time are not fundamental, but emergent properties of something deeper. Perhaps consciousness plays a role in how reality crystallizes from quantum possibilities. Perhaps the universe is far weirder than any current theory suggests. What seems certain is that the quest for unification will continue. Humans have an innate drive to understand the world. We cannot help but pursue deeper and deeper levels of explanation. We cannot accept that some things are simply unknown. We build instruments of greater and greater power and sensitivity. We develop mathematics of greater and greater sophistication. We collaborate across nations and generations, dedicating our lives to questions that may not be answered until long after we die. This drive to understand is perhaps the most fundamentally human of all impulses. It has led us from caves and fire to cities and science. It has transformed our world. It will continue to transform us. The practical applications of fundamental research often emerge decades or centuries after the discovery. Maxwell's unification of electricity and magnetism seemed purely theoretical. Yet it led to wireless communication that now connects billions of people. Quantum mechanics seemed like abstract mathematics with no practical relevance. Yet it enabled transistors, semiconductors, lasers, and all of modern electronics. Relativity seemed like impossible geometry with no application. Yet it revealed that mass and energy are interchangeable, leading eventually to nuclear power. The unified field theories physicists pursue today may seem equally impractical. Yet if history is any guide, the understanding they provide will eventually transform technology and human civilization in ways we cannot yet imagine. Or it might reveal that certain technologies are fundamentally impossible, limits built into the structure of reality itself. The search for unification connects to the deepest philosophical questions about the nature of reality. Is the universe fundamentally simple or complex? Is it reducible to simple principles, or is complexity irreducible at certain levels? Do the forces we observe correspond to something real in nature, or are they merely human constructions useful for making predictions? Does understanding the forces answer the question of why there is something rather than nothing? These questions move beyond physics into metaphysics and philosophy. Science can address the first 4 questions through observation and reasoning. The 5th question lies forever beyond science. It is the question that philosophers and theologians have wrestled with for millennia. Yet knowing the forces does not make the universe less mysterious. It only reveals deeper mysteries beneath. We understand gravity, yet we do not know why massive objects attract each other. We can describe it mathematically, predict its effects precisely, yet the why remains opaque. Similarly, for all the forces, we can describe their behavior without understanding their ultimate origin or purpose. We can predict with extraordinary accuracy without truly comprehending what underlies the predictions. In this sense, science does not solve the deepest mysteries, it deepens them. The more we learn, the more apparent it becomes that reality is stranger and more wonderful than we imagined. The future of physics likely depends on new ideas we have not yet conceived. String theory and loop quantum gravity represent the best thinking of today's brightest minds. Yet both may be superseded. Perhaps some young physicist reading these words will have the insight that changes everything. Perhaps the next great unification will come from an unexpected direction, from someone working outside the mainstream. The history of science shows that progress often comes from those willing to question established assumptions. Einstein was outside the academic mainstream when he developed relativity. Planck was doubted when he proposed quantization. Darwin faced tremendous opposition to his theory of evolution. Yet each persisted and changed the course of science. The next revolutionary insight may come from someone with equal determination and originality. In the meantime, the forces continue their invisible work. Gravity pulls stars into galaxies and keeps planets in their orbits. Electromagnetism binds atoms together and creates light. The weak force powers the sun and enables radioactive processes. The strong force holds nuclei together and makes complex matter possible. These forces work ceaselessly, asking nothing from us, asking for no recognition or gratitude. They simply are. They simply do. The universe continues its expansion. Matter continues to organize into increasingly complex structures. Life continues to emerge where conditions allow. Consciousness continues to develop in the universe, becoming aware of the forces that created it. Perhaps this is the ultimate purpose of the forces, not to be unified into a single abstract principle, but to create a universe capable of observing itself, to create minds capable of wonder, to create beings capable of asking questions about the very foundations of existence. Your body contains approximately 7 billion atoms. Each atom is held together by electromagnetic forces. Each nucleus is held together by the strong force. Each atomic electron moves in ways determined by quantum mechanics, which is governed by the electromagnetic force. Your cells operate through chemical reactions, which are electromagnetic phenomena. Your muscles contract through electromagnetic interactions. Your neurons fire through changes in electromagnetic charge across their membranes. Your consciousness arises from electromagnetic activity in your brain. Every thought, every emotion, every moment of awareness depends on the forces working exactly as they do. You are not separate from the forces. You are a product of them. You are a temporary arrangement of matter, held together by these invisible forces. When your time ends, the atoms that make up your body will disperse. The forces will scatter your constituent parts into the cosmos. Yet those atoms will continue to exist. They will continue to be governed by the same forces. Perhaps they will become part of other living things. Perhaps they will join new stars. Perhaps they will exist forever in some form, subject to the eternal reign of the four forces. In this sense, you are eternal. Your physical form is temporary, but your atoms are permanent. Your consciousness is temporary, but the matter that created it is eternal. The forces are eternal. They have existed since the Big Bang and will exist until the universe reaches its final state, if such a state exists. Think for a moment about what you have learned. The universe is governed by four forces. These forces are fundamentally simple, described by elegant mathematics. Yet from this simplicity emerges infinite complexity. From these four forces arise atoms, molecules, stars, planets, life, mind, and consciousness. Everything you see, everything you touch, everything you think is a manifestation of these forces. The fact that you can understand these forces is itself a manifestation of these forces. Your brain is a product of the forces. Your intelligence is a product of the forces. You are using the forces to understand the forces. This is the profound paradox at the heart of science. The universe observing itself through human minds. Matter becoming aware of the laws that govern matter. The Four says, understanding the forces. This is the deepest magic in existence. Not magic in the sense of violating natural law, but magic in the sense of sheer wonder at how reality is structured. The four fundamental forces will continue their work long after you are gone. They will continue for billions of years, reshaping the cosmos, creating new structures, destroying old ones. Stars will be born and die. Planets will form and be destroyed. Life will emerge on countless worlds and develop in countless forms. Consciousness will arise and contemplate the forces that created it. Perhaps someday, consciousness will become unified with the forces in a way we cannot yet imagine. Perhaps the next step in evolution is not biological, but a merger of mind and physics. Perhaps intelligence will eventually understand and control the forces directly, reshaping reality itself. Or perhaps the forces will remain forever mysterious, always receding beyond the horizon of understanding, always off, airing new questions for each answer discovered. What is certain is that the journey continues. The quest for understanding will not end. As long as minds exist capable of wonder, they will pursue deeper understanding of the forces that make existence possible. They will ask bigger questions. They will devise more powerful experiments. They will develop more sophisticated mathematics. They will come closer and closer to the unified theory that reveals all forces as aspects of one fundamental principle. Or they will discover that unification is impossible, that the forces are truly independent, that the universe is built on multiplicity rather than unity. Either way, the pursuit itself is worthwhile. The pursuit of understanding ennobles the human spirit. It connects us to something larger than ourselves. It makes us participants in the grand project of comprehending reality. Your role in this project is simply to wonder, to look at the world around you with eyes that see not just the surface, but the forces beneath. To understand that every moment of your existence is made possible by forces beyond your perception. To recognize that you are connected to the entire cosmos through these forces. To feel gratitude for the precise balance that allows you to exist. And perhaps, to contribute in some small way to humanity's understanding of these forces. You may not be a physicist. You may never make a discovery that advances science. Yet simply by learning about the forces, by understanding how they work, you become part of the collective human enterprise of comprehension. You join the millions of people throughout history who have looked up at the stars and asked why. You become part of the conversation that has defined humanity since the beginning of conscious thought. The forces remain invisible. They do not reveal themselves to casual observation, yet they are the most real aspects of existence. More real than matter, which is made of them. More real than energy, which is their manifestation. They are the foundation upon which everything else rests. They are the final answer to the questions what and how. They are the boundary of what science can explain. Beyond them lies the question why, which science cannot answer, but only humans can ask. You have now walked through the invisible landscape of the four forces. You have seen how they shape every atom, every creature, every moment of existence. You have glimpsed the profound beauty of a universe governed by elegant mathematical principles. You have felt, perhaps, the wonder and awe that comes from truly understanding the cosmos. This is the gift of science. Not certainty, but wonder. Not final answers, but better and better questions. Not the end of mystery, but a deeper appreciation for how mysterious reality truly is. Let this knowledge settle into your mind gently. Do not struggle to grasp it all at once. These are concepts that have taken centuries for humanity to develop. They are concepts that physicists spend their entire lives studying. It is enough to understand the basic outlines of how reality is structured. It is enough to know that there are 4 forces, that they shape everything you are, that they remain partially mysterious. It is enough to feel, in your body and mind, the profound truth that you are made of the cosmos. The atoms that comprise your being originated in ancient stars. The forces that hold you together originated in the Big Bang. You are not separate from the universe. You are the universe experiencing itself. The cosmos examining its own structure through your eyes. This is not poetic metaphor. This is scientific fact. The iron in your blood came from a star. The calcium in your bones came from a star. The oxygen you breathe came from a star. You are stardust given consciousness. You are the universe become aware of itself. The forces have shaped the cosmos for billions of years. In you, the cosmos has finally become capable of understanding its own forces. This is the ultimate achievement. This is the highest expression of what the forces can create. Not perfect order, but conscious reflection. Not eternal stability, but the ability to wonder and ask why. As you move forward through your life, carrying this knowledge with you, remember that every moment is made possible by forces beyond your perception. When you feel the ground beneath your feet, you feel the electromagnetic repulsion of electrons in matter, keeping you from falling through. When you see the sun, you see electromagnetic radiation, created by nuclear fusion, powered by the weak force. When you taste food, you experience the electromagnetic interactions of molecules with your taste receptors. When you think, you experience electrical and electromagnetic activity in your brain. The forces are not abstract ideas. They are intimately present in every moment of your existence. They are as real as the breath in your lungs and the blood in your veins. More real, perhaps, because without them, there would be no lungs, no blood, no body at all. The mathematics of unified theories often reveals unexpected connections. The equations that describe the strong force contain terms strikingly similar to those in the electromagnetic equations. The symmetries underlying the weak force echo symmetries in other fields of physics. These parallels suggest that beneath the surface diversity, unity indeed exists. Physicists search for the mathematical structure that naturally encompasses all these symmetries. When found, it would be like discovering that Shakespeare, Mozart, and Einstein were all expressing the same underlying truth in different languages. The language of mathematics would finally reveal the common grammar beneath apparently different forces. This is the dream that sustains theoretical physics, not certainty of discovery, but hope of unveiling hidden unity. Hope that reality is more coherent than it appears. The experiments that test unified theories sometimes yield surprising null results. Scientists design experiments specifically to look for evidence of unification. They look for decaying protons, for evidence of supersymmetric particles, for deviations from the standard model. Year after year, with increasing precision, they find nothing. The standard model holds up. No new particles appear at the energies achieved so far. This could mean unification occurs at energies we cannot reach. Or it could mean that current unification theories are wrong. Or it could mean that nature is not unified in the way we imagine. The history of science includes many beautiful theories that nature rejected. The universe does not care about aesthetic elegance. It operates as it operates, regardless of what we imagine it should do. Sometimes reality is more complex than our best theories. Sometimes it is simpler. Always it surprises us. Yet precision measurements continue to reveal hidden consistencies. When physicists measure the weak force strength and the electromagnetic force strength at the same energy scale, they find values consistent with the electroweak unification. When they measure the running of coupling constants, how force strengths change with energy, the values match predictions made decades earlier. These confirmations provide confidence that the direction of unification is correct, even if the final unified theory remains unknown. It is like assembling a vast jigsaw puzzle. Each piece discovered, confirms that the pieces are meant to fit together. Yet the full picture remains hidden until the last pieces are placed. The physicists of today may not live to see the final unification. They work on behalf of future generations, building the foundation upon which ultimate understanding will rest. The concept of emergence becomes increasingly important in modern physics. Emergence describes how complex behaviors and properties arise from simple underlying rules. A single water molecule has properties quite different from bulk water. When billions of molecules gather together, new properties emerge that no single molecule possesses. Wetness emerges from water molecules. Solidarity emerges from atoms. Life emerges from chemistry. Consciousness emerges from neurology. In each case, higher-level properties cannot be predicted simply by studying individual components. They require understanding interactions and organization. Many physicists now believe that the four forces might themselves be emergent properties, not truly fundamental, but arising from some deeper unified substrate. The forces we observe might be like wetness in water. They seem fundamental when experienced directly, but they are really manifestations of something more basic operating at smaller scales. If this is true, then seeking to unify the forces is not the final step, but an intermediate step. Beneath unification lies something even more fundamental that we have not yet conceived. Space and time themselves may emerge from this deeper level of reality. Quantum gravity theories suggest that space-time is not a fundamental background in which particles move. Rather, space-time is built from quantum relationships between particles. If you removed all particles and fields, space-time would not remain. There would be no stage upon which physics acts. This seems counterintuitive because our experience is of particles moving through space over time. Yet the universe does not care about our intuitions. At the deepest level, space and time may be illusions created by our brain's attempts to organize quantum information into concepts we can comprehend. The real nature of reality may be something we cannot currently imagine, something that bears no resemblance to space and time as we know them. Yet this incomprehensible reality somehow generates the space-time we experience. The forces we observe somehow generate the universe we perceive. This brings us to the deepest mystery of all. Not why the forces have the values they do, but why there are forces at all. Why does the universe obey laws? Why do the laws take the form they do? Could the laws be different? Could a universe exist without laws? These questions move beyond physics into metaphysics. Science proceeds by assuming that laws exist and trying to understand them. But science cannot explain why laws exist. It cannot answer the ultimate why. This is the boundary of science. Beyond it lie questions that philosophy and theology address. Beyond it lies the realm of meaning and purpose that science cannot touch. Yet standing at this boundary, looking across it, science provides profound insight. The laws are elegant. The forces are balanced in ways that suggest deep intentionality. The universe demonstrates mathematical beauty that seems almost purposeful. These observations do not prove design or purpose, but they invite contemplation. They suggest that reality is stranger and more wonderful than we might have imagined. This is the knowledge that unites all humans. Every person on Earth is made of the same atoms, governed by the same forces. Every person is connected to every other person through the universal constants that shape matter. Race, nationality, and ideology separate humans. But the forces unite us. The forces make us all members of one species, inhabitants of one planet, participants in one cosmos. Understanding this shared foundation can foster compassion and connection. When you recognize that the person next to you is made of the same atoms and governed by the same forces as you, the barriers between self and other dissolve. You are not truly separate. You are localized concentrations of matter held together by forces that permeate all space. You are one organism among billions, all made of stardust, all governed by forces, all part of one cosmos, experiencing itself from different perspectives. The four forces are not finished with their work. They will continue to shape reality for billions of years to come. They may eventually drive the cosmos toward a final state, whether that be infinite expansion, ultimate collapse, or some other fate we cannot yet imagine. They may be unified into a single force at the highest energies, or they may remain forever separate, each governing its own domain. The future is not yet written. Reality is still in the process of becoming, and you are part of that process. Your thoughts, your actions, your choices ripple through the cosmos, influencing how matter organizes and how the forces direct that organization. You are not a passive observer of the forces. You are an active participant in their ongoing work. The forces created you, and now you are helping to shape how the forces manifest in the universe. This is the profound responsibility and opportunity of conscious existence, to know the forces, to understand them, to use them, to grow through them, and perhaps, one day, to contribute to their unification and our ultimate comprehension of reality. So here at the end of this long journey through the invisible forces, let yourself pause for a moment. Close your eyes if you wish. Feel the weight of your body held to the earth by gravity. Feel the electromagnetic energy flowing through your nerves. Feel the slow burn of fusion in the distant sun, powered by the weak force, arriving as warmth on your skin. Feel the immense strength of the strong force holding every atom of your being together at the nucleus. All four forces are present with you now. They have never left you. They were present before you were born and will be present after you die. They are the invisible companions that make existence possible. They are the gentle architects that shaped you grain by grain from stardust into conscious being. You need not fully understand them to appreciate them. You need only acknowledge their presence and their power. You need only remember that you are not separate from these forces. You are made of them. You are their expression. You are the universe's way of knowing itself through these invisible currents that flow through all things. If you have found value in this exploration of the fundamental forces, in this slow and patient walk through the invisible landscape that underlies reality, consider sharing this with others. Like, subscribe, or tell a friend. Your engagement helps others discover the wonder that awaits when we look closely at how the universe truly works. The forces do not require our recognition or appreciation to continue their work, yet perhaps sharing this knowledge is part of our role in the cosmos. We are the universe's way of spreading understanding of itself. We are consciousness serving the forces, helping them achieve their ultimate expression through awareness and contemplation. This is both privilege and responsibility. Use it wisely. For now, just breathe. Allow the weight of knowledge to settle gently on your mind, like snow falling on a winter landscape. Do not strain to hold it all. These concepts will live with you now. They will color your perception. When you look at anything, you will see the forces working beneath the surface. When you touch anything, you will feel them. When you think, you will know that thought itself is a manifestation of these invisible powers. Let this knowledge comfort you. Let it fill you with wonder. Let it connect you to everyone and everything that has ever existed. The atoms that make up your body have been assembled and reassembled countless times throughout history. They have been parts of stars and planets, of dinosaurs and flowers, of ancient peoples and future beings. The forces have been rearranging the same materials for billions of years, creating endless forms and structures. You are the latest creation in this eternal artistic work. You are a temporary masterpiece that will eventually dissolve back into the cosmic material, there to be reformed into something new. This is not sad. This is beautiful. This is the eternal dance of creation and dissolution that makes the universe eternally fresh. Rest now in the knowledge that you are supported by forces stronger than mountains, by mathematics more beautiful than any art ever created, by physics that is ultimately more wondrous than any fiction. You are held safe in the arms of the cosmos. All is well. All will continue, changed perhaps, but continuing. Sleep well, knowing that even as you dream, the forces are at work, building the future, sustaining existence, weaving the tapestry of reality one quantum event at a time. You are part of this. You are welcome here. You belong to the universe as much as the universe belongs to you. Good night, traveler. May your dreams be filled with the beauty of forces flowing through space and time, binding everything together, creating the cosmos anew with each passing moment.